on the next episode of Anna Thought Her Loom was working. It was not. So I spent the last 40 minutes talking to nobody. And we got through 3 questions. This video will go through the solutions in Python for questions 16 through 21. 20 will be at the end because I recorded that right when I was starting to do this as like my own kind of personal challenge to myself. So it wasn't a loom, it was just a screen recording with me talking while I was doing it. But I will, without further ado, jump into my solutions for these, and then we'll live code the remaining ones. So without further ado, let's jump into 16, which is the threesome closet. So given an integer array nums of length n and an integer target, find 3 integers in num such that the sum is closest to target. Return the sum of 3 integers. You may assume that each input would have exactly 1 solution. So let me move my big old head out of the way and show you these examples and these constraints, and then also my solution. So I started out by using a sorting the input array in ascending order, and then initializing the closest sum as a positive infinity. From there, I used the pointer element for the left to point next to nums I, and then for the right, I had to go to the last element in the array. So here is the while part of this area. God, it calculates the current sum. So the current sum is nums I plus nums left plus nums right. Then after that, this if area returns the exact match. This area is where I tripped up actually a little bit. I had an issue because my logic wasn't quite right, but essentially hopefully I'm not going to mess this up saying this. The closest sum, we have to update the closest sum if the current sum is closer to the target. So this turns the current sum into the closest sum, essentially. And then we had to increment the left pointer for the larger sum, and then decrement the right pointer. And then obviously we finished with the closest sum. So I hope that was a decent explanation. This was my submission 24 minutes ago. It wasn't too bad. So then we go on to the next one, which was 17. It really brought me back to my Motorola days. I actually was having a field day talking to myself about this. So this is the number 17, letter combinations of a phone number. So given a string containing digits from 2 through 9 inclusive, return all the possible letter combinations that a number would represent. Return the answer in any order. A mapping of digits to letters, just like the telephone buttons, is given below. Note that 1 does not map to any letters. So we did, in the video of 11 to 15, I think, we did the Roman numeral. So I did the same sort of approach with this. I saw other approaches to this, but essentially I just created a directory that just mapped each of the digits to the corresponding letter. That just seemed like an easy way to start. And then I created this combinations area down here, the list to store the letter combinations. Gosh. Then here I used the helper function because that's who I am. And then I had this base case here where when there are no digits left. And then here was how we got the first digit in the remaining digits. Then I ended with a recursive call for the remaining digits. And that's basically this solution. I tested, I submitted it, it was fine. So that's that, we can go on to number 18. I think I just submitted this one. Yeah, 7 minutes ago. Because I was going on to 19. I was like, why do I not see my little face anymore? So number 18 is the foursome. It's fine. It's fine. LeetCode is out here doing the most. So given an array nums of n integers, return n array of all the unique quadruplets. Nums A, nums B, nums C, nums D, such that. Then they give you this information here. And you may answer in any order. Here are the examples, and here are the constraints. So let me go down here. So this one, I started kind of in a similar way where I sorted everything in ascending order, and then I made a list here to store the unique quadruplets. So down here, this area, basically, I skipped quadruplets if nums I to avoid the duplicates. And then I did that down here also for nums j. And then I did the pointer elements here so that this would be the element next to nums j. For some reason in my brain I thought that was nums I. And then obviously the right was for the last array. And then this one calculated the current sum. This one found the quadruplet. This one skipped duplicates of nums left to avoid that duplication. And then this one avoided nums right to not have that duplication. And then this was for incrementing the left pointer. This was for the right pointer. And then this was incrementing the left pointer for a larger sum. And this was decrementing the right pointer for a smaller sum. So I'm hoping that made sense to you all. And now we can get into, I'm popular. Number 19. Hopefully this will, I already know I don't like it. Okay, so number 19, remove nth node from the end of the list. Given the head of a linked list, remove the nth node from the end of the list and return it to its head. Fantastic. So here is the, listen, JoJo's got to make her appearance. This is JoJo. She is my little coding cat. She's great. She's good luck. Yeah. So if anyone is using this as a way to, segue into a different career path, prep for an interview, now is your time. JoJo has graced your presence. Okay, so looking at this and the constraints. Okay, so my first thought is to create a dummy node as the head of the list and then calculate the length of the list, because then we could find the node to remove. That just like logically, and then at the end we'll remove the nth node. Let's try that. I'm all for giving that a go. So I'm going to create this dummy list. This list node 0, and then dummy next head. So then we want to calculate the length of the list. So length. JoJo's trying to go outside. She cannot because it's dark out. Length, and then we're going to do node head, And then while node length is 1, then node equals node next. Okay, then we have to find the node to remove. So let's go and do node dummy. So for in range length n. I remember doing something similar to this in one of my little coding classes. It was actually really fun. And this next part, we'll have to remove the node. So we do node next equals node next next. And then dummy next. Node, got the list. We figured out the length of the list. We found the node to remove. Let's give that a try. That is what I'm talking about. That is what I'm talking about. Internal, I saw that internal error, you guys, and I was like, of course. This one I'm just breezing through. Of course there was an error. Okay, so I hope that made some sort of sense to people. Like I said, I'm going to do 20 at the end of this video, but we'll just breeze on by. This is what I had. This is when I submitted it. Obviously, that was like a couple days ago now. So that'll be at the end of this video. So let's go ahead and scoot on over to 21. Okay, 21. Merge two sorted lists. That's my cat's toy. I can't. So you're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists in a one sorted list. In a one sorted list? Okay. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. She's giving the same vibe as the one before. She's giving, we're gonna start her the same. It's how we're gonna start this. So we're gonna create a dummy node, and we're gonna, as the head of the merged list, we're gonna start there. You guys know how we're gonna start this. I already know. We're gonna start it. Nice. And then hold on. Let me just reread this again to make sure I'm reading this correctly. I saw this and I was like, these nodes. Okay. Let's see. We need to get a pointer at the current node. And then we need to merge them until one becomes empty. Right? Yeah. Okay, so let's try that. So let's say current dummy. So that'll be the pointer. So while list 1 and list 2, if list 1, the value is less than or greater, or equal to list 2. You guys can't see JoJo, but it is like 11 o'clock at night, and she is starting her happy hour, if you will. I.e. her witching hour. Okay, so what I'm doing is I'm merging the lists until one of them becomes empty. I can't with her. And I want list 2. I'm going to do the same structure as before, as list 2 next. List 2 next. And then current equals current next. Okay. I really hope you guys can hear that. This is so funny. Okay. So we need to append. We need to append the remaining nodes of the non-empty list. I need to finish with this question because she is about to terrorize my house. So if list 1 current next, then it's list 1. List 2 current next, list 2. Why am I doing all these dots all the time? Someone get me out of my head. And we're gonna return the dummy next. Okay, I'm hoping that's right because JoJo's about to. It is. Okay. You can give him a praise. Okay, let's submit this bad boy and call it a night. I need to gear myself up. Yes. Oh, that's hot though. Okay, thank you guys so much for dealing with me. I'm gonna go and enjoy the rest of my night. Here we are. No submissions yet. So this is number 20, valid parentheses. So given a string S containing just the characters parentheses, curly brackets, square brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the time at the same type of brackets. Geez Louise. Open brackets must be closed in the correct order. Every closed bracket has the corresponding open bracket of the same type. So we go down to these examples here. These are pretty self-explanatory. Like this isn't the same, so it's false. And then we have our constraints. So I think how I want to determine if a string of brackets is valid. We should do like a for if situation, so that we can say if like the character S bracket values are stacked, or if not, then return false, else return false kind of situation. So we should do something here where we say like stack equals brackets. So let's say stack. I'm just trying to think about this out loud. And then we should say brackets. And then I will have to do these individually. So we have to make this a partnership. So I'm doing that by doing this for each. So we're going to do that for this bracket. And I'm going to do a comma for just the regular parentheses, not bracket. And then we're going to do... Did I say curly brackets? Yeah, it was curly brackets, but I just panicked. I'm going to put a space between that. And then here we're going to do that bracket, delete that, and then we're going to do the curly bracket. Oops. Okay. Okay. So if the character is an opening bracket, it's pushed onto the stack. If the character is a closing bracket, then it's checked on top of the stack. That's what this is representing. So let me go down and say, let's start a for if-else statement. Okay, so if the stack is empty, or on top of the stack doesn't match that opening bracket, then the string is invalid and false is returned. That's what I'm thinking this is going to have to do. So let's say for character in S, if character in brackets values, stack append, and then we'll say in brackets keys, if not stack or stack pop. What should I do here? This is, I'm not sure. So returned false. I can get that to be returned false. So if the top matches the corresponding bracket, it is popped from the stack. That's what I'm trying to do here. So I guess I should say brackets char, and then say return false. Oh my gosh, my phone is going off all morning. And then we'll say else return false. So that way, if the character is neither an opening bracket nor closing bracket, then it's returned as false. So then after iterating through all the characters in S, the stack should be empty for the string to be valid. So if it's not empty, there are enclosed brackets and a false is returned. And we need to do maybe return, I don't know, len stack, like the length of the stack should be equal to 0. So if the stack is empty, the string is valid and true is returned. If that makes sense. So basically this code is going to keep track of the opening brackets it encounters. Yeah. Let's run. And chart. Oh my god. We were just making fun of myself earlier for this, so. Oh, values. This is so bad. Why am I like this? Okay. I'm sorry. Obviously I don't subscribe to LeetCode. Oh my, this is why I can't do this first thing in the morning. I did the other one just fine, but brackets is kicking my, ooh, here we go. True, false. So that's good. Okay, so it noticed all of these were true. They're the same. They open and closed of the parentheses, and then this one was open, close, but it was different. Sweet. So let's go ahead and submit that. And then from here, okay, nice, cool. Let's look at other solutions. I'm thinking there's going to be a lot of people who do something similar to this also. And I guess we're doing Python 3. Oh my gosh. Okay, yeah, similar. This is this is nice. Okay, so that's one other Python solution. Let's see what this Python solution looks like. Oh my god. It's that same, it just has notes. I guess I could add notes to mine. You guys can kind of hear that I don't really know what I'm doing. Hence why oh my god. Hence why I'm trying to do it better. Actually, you know what? Let's add our solution today because those first two don't have it. So we might as well add it and see if it can help someone else with their solution. I don't think I did it the best. Thank you. What? Okay. So